Today in Math 30-1, we're going to cover topic 3.4, Part A, which is just the first two examples. Tomorrow we're going to do the second two examples. This is about equations and graphs of polynomial functions. Let's get going. First of all, as in the case of quadratic functions, the zeros of any polynomial function correspond to the x-intercepts of the graph and to the roots of the corresponding equation, setting it f at x is equal to 0. For example, the function f at x is equal to x minus 1 times another x minus 1 times x plus 2 has two identical zeros at x equals 1 and a third zero at x is negative 2. Those are the roots of the equation x minus 1 times x minus 1 times x plus 2 is going to equal 0. If a polynomial has a function of x minus a that is repeated n times, then x minus a is said to be a zero of multiplicity n. The function f at x equals x minus 1 squared times x plus 2 has a zero of multiplicity 2 at x equals 1, and the equation of x minus 1 squared times x plus 2 equals 0 has a root of multiplicity 2 at x equals 1. If you consider the graph of the function, you'll notice that the graph goes straight through at x equals negative 2. That means a multiplicity of 1. And then it's going to come down, be tangent at x is equal to 1, and go back up. It's going to stay on the same side of the line, but just touch the x-axis at x equals 1. That's how the graph is going to behave. So we can say that at x is equal to negative 2, there's a zero of multiplicity 1, and the sign of the function is going to change as you go from one side of it to the other. However, at x is equal to 1, that's where the zero of multiplicity 2 is, the sign of the function doesn't change. In example 1, we're going to analyze these graphs of polynomial functions. For each graph, determine the least possible degree, the sign of the leading coefficient, the x-intercepts, and the factors of the functions with the least degree possible, and the intervals where the function is positive and the intervals where it's negative. So let's look at A. Notice the graph passes straight through at negative 4, so we can say that it's going to be a multiplicity of 1 at that point. Then it passes straight through again at negative 2, so that'll have a multiplicity of 1. And then it passes straight through again at x equals 2. So that'll also have a multiplicity of 1. That means the whole thing has to be a degree of at least 3. So there's roots at negative 4, negative 2, and positive 2. We can say that this graph is going to have factors of x plus 4 times x plus 2 times x minus 2. The degree has got to be at least 3. The leading coefficient is going to be positive. How do I know that? Because of the end behavior of the graph. Notice it goes up to the right. The last part here, it's going to be negative when x is less than negative 4. It's going to also be negative when x is less than positive 2 and greater than negative 2. It's going to be positive when x is between negative 2 and negative 4, and when x is greater than positive 2. That's how we do it. In B, it's going to have a multiplicity of 1 at x is negative 5. It's going to have a multiplicity of 1 when x is equal to negative 1. And here, where x is going to equal positive 4, it's going to have a multiplicity of 2, because the sign is going to stay the same, and it's just going to be tangent at that point. Again, our leading coefficient is going to be negative this time because of our end behavior. factors are going to be x plus 5 times x plus 1 times x minus 2. Minus 4, sorry. And that will be to the power of 2. So we can say it's going to be positive when x is less than negative 1, but greater than negative 5. And it's going to be negative on 3 different places. When x is less than negative 5, when x is between 2 and negative 1, and when x is greater than negative 2. Your turn. Take a moment, do the same thing for this graph, and then I'm going to post the results. There we go. In the end, we can say y is equal to negative of x squared, x plus 2 squared times x minus 3. That's a possible equation, but we can't be certain because we don't know the a value. That would be the number out front. In example 2, we're going to analyze equations and sketches of graphs of polynomial functions. They want us to give, for the first one, y is equal to x minus 1 times x plus 2 times x plus 3. They want us to state the degree. Well, 3 x's in there. That's going to be a degree 3. The leading coefficient, notice that there's nothing out front except a 1. That would be assumed it would be a 1. The end behavior, well, since it is positive 1, that means it's going to be up to the right, up in quadrant 1. There's going to be zeros at positive 1, negative 2, and at negative 3. The y-intercept, if we look at the last number, multiply those together, negative 2 times negative 2 times, anyways, let's move on. If we have intervals, let's look at where our intervals are. Our intervals are going to be, x has got to be less than negative 2, but greater than negative 3, and greater than 1. Negative, when x is less than negative 3, and between 1 and negative 2. Excuse me, in B. The degree is 4. Leading coefficient this time is a negative 1 because it just says negative out front. That goes down into quadrant 4. There's zeros at negative 2, and there's an x-intercept at 4. Y is equal to 32 will be my y-intercept. This is what the graph is going to look like. It's positive for x less than 4, greater than negative 2. And it's going to be negative when x is less than negative 2, but greater than positive 4. And the last one. This time, it's not given in factored form. Guess what? We got to factor it. We know that the degree is going to be 3, and my leading coefficient is negative 2. So let's go and figure out the rest. First of all, I have to factor out the negative 2 from the leading coefficient. That's my a value. And then I'm going to go ahead and figure out how to factor the rest of it. My last term is 2, so I'm going to use the integral zero theorem and the factor theorem and look at the factors of 1, negative 1, positive 2, and negative 2. Let's start with 1. P at 1 is going to equal 0. So I've found one of the roots. That means if I divide this by 1, bring down the 1, 1 times 1 is 1, add them up I get 1, 1 times 1 again is 1, that adds up to negative 2, 1 times negative 2 is negative 2, that adds up to 0, so I can say now that it's going to be y is equal to negative 2 times x minus 1 times x squared plus x minus 2. Then I can further factor it to become x plus 2 times x minus 1. So here we go. it's going to go down into quadrant 4. Well, the equation then is y equals negative 2 times x minus 1 squared times x plus 2. Also, this is a degree of 3. There's going to be zeros at negative 1 of multiplicity 2, and there's going to be an x-intercept at negative 2. Y-intercept is at negative 4. So now when you look at this, there's your graph. It's going to be positive. Well, it's only going to be positive when x is less than negative 2. And it's going to be negative between negative 2 and positive 1, and when x is greater than negative 1. There we go. This time, your turn. You're asked to do this one on your own. I'm going to post the results for the first one, so it's a good time to stop it and do it. There's the results. Now you can do the second one. Stop and do it. And your assignment for this section is to do page 147, numbers 1 to 4.